Okay, so we're starting 1.6, and the way this is set up, unfortunately, I'm just going to have to scroll up and down as we answer these questions. So what we're supposed to do is answer these questions and then go back and write these rules for what it means to be a continuous function, which you should know about continuity from pre-calculus, but that was a lame explanation. We have a better explanation in calculus, so that's the way we're going to do this. So looking at x equals -6 is the first one. Well, as we look at it, it's an open circle here. It's supposed to be at 5, which I don't know if it copied well for you guys, but mine looks like it's off a little bit. But anyway, it is undefined. All right. So what's the left-hand behavior? Well, on the left side of x equals -6, it's getting closer to 5. On the right side, it's getting closer to 5. So because the left side equals the right side, the limit does exist, and that value is 5. However, it is not continuous. And we talked about in pre-calculus that if you have a hole in the graph, we do not say it's continuous. And that's exactly what's happening here. So as we look at x equals -3, this time it is defined. It is defined because we have it closed out right here. What's the value on the left side? Well, the left side, it's getting closer and closer to 2, it looks like. On the right side, it's getting closer and closer to -4. Well, the left side does not equal the right side, so this limit does not exist. And if you think back to pre-calculus, I think you would all say it is not continuous at that value. So moving forward, look at x equals 0. Well, at x equals 0, right here, it is defined. It's at -1. The left side, it's approaching -1. The right side is approaching -1. I guess I should have wrote down the defined value here. Defined. And that defined value is -1. The left side is -1. The right side is -1. Since the left side equals the right side, the limit does exist, and it is -1. And we would say that it is continuous at x equals 0. Look at x equals 2. X equals 2 has a vertical asymptote. It is undefined. Undefined. Now, as far as the limit on the left side, let's just go ahead and write infinity, but I recognize that earlier I talked about does not exist. The right side is going negatively infinite, but again I recognize it says does not exist. There's only one right answer for the limit though, because the left does not equal the right, even in behavior. And it's got a lot of things wrong for it. It is not continuous. So let's look at x equals 6. At x equals 6, it is defined. We have a closed dot. At least mine looks like it's off a little bit, but it's supposed to be at this value of x equals 1. So it is defined. That value is y equals 1, sorry. At x equals 6, it's y equals 1. Now the left side, it's getting closer to 4. On the right side, looks like it's getting closer to -2. 4 on the left side, -2 on the right side. These two values are not the same, so the limit does not exist. So therefore, well, I haven't really explained the calculus definition, but these are the pieces we're looking at. But from pre-calculus, you should have been able to say that no, it's not continuous. There's definitely a jump in the graph. So then as we look at x equals 8, it is defined. Looks like it's -4. As we look at the left side of 8, looks like it's getting closer and closer to -2. Same with the right side, getting closer and closer to -2. -2 and -2. So the limit does exist because the left equals the right, so that is your limit. But what it boils down to, let me fix it. I thought I hit the eraser. There we go. That was bothering me. Probably bothering you too. That this is not continuous. And from pre-calculus, that was pretty evident because there was a break in the graph, a hole, and then it jumped down and jumped back up. So look at these. I mean, really there was only one time it was continuous. And what was special about this x equals 0 that made it continuous, and why I asked these types of questions? So since we're looking at where x equals a, I'm going to write everything in terms of f of a. Well, I guess this is in terms, we can do this in terms of g, but remember it's just function notation, so it does not matter. But the first thing that we want to identify is that the function is defined at that point. The second thing that we want to make sure is that the limit as x approaches a of that function, g of x, but remember it's just the name of it. Don't get hung up that I'm using g instead of f or something. So the limit must exist. Now you could expand on this. Maybe I'll expand this with a different color. That's basically saying that the limit from the left side of g of x must equal the limit on the right side of g of x. So in your three-part, you might actually split up part 2 into 2 different parts. So it must exist, and in order to exist it has to equal some numerical value. So let's put it all together. For part 3 is that the limit as x approaches a of g of x must equal the defined value that we found from part 1. So I realize that some people try to shorten this, but this is what AP Calculus teachers are looking for when they grade your test in May. Well, they actually grade it in June or July, but you take it in May. And one more thing is go ahead and give the numerical value. Because if you just say that the function's defined and the limit exists and they equal each other, you might not get full credit. You actually want to give the numerical L value, whatever the limit is at those points. So let's actually look at a few problems. And we're just determining with a 3-part definition if these functions are continuous. I think from pre-calculus you guys did good enough to just look at x equals -8 and see that there's definitely a jump in the graph there. So you would say that it is not continuous, or sometimes we use the phrase discontinuous. That means not continuous. Let me know if I use a weird word along the way. But what part is it breaking? Well, first of all, what is this called? G of x is defined, so that's not what's wrong. The limit is defined. It's this just because it's a whole. But the issue is that the limit as x approaches -8 of this function does not equal g of -8. So it's part 3 that this one breaks. So as we look at -6, right here, is x equals -6 defined? Yep, it's right here. Does the limit exist? Sure. They approach the same thing on both sides, and those two values are the same. So this is continuous. Act excited for a second. X equals -4, definitely discontinuous. If you go back to pre-calculus, and we talked about it's a jump in the graph, so that there's an issue. So which parts is this breaking? Well, part 1, it's defined, so that's not an issue. From the left side does not equal the right side, so maybe that's all you write down. But I'm going to write down the other one as well. Limit as x approaches -4 of this function does not exist. Okay, maybe you even write out limit on the left side of -4 does not equal the limit on the right side. You don't have to. And I'm not even going to write down the other. Well, maybe I should because I have all this space. And I verbally said everything, I just didn't write all of it down. But you're just going through your checklist and you're writing out all of the different things. So since these are your notes, I'll leave it up to you how much more you want to write out. But I really want to get to these examples. Okay, because in order for functions to be continuous, they need to be defined. All right, so if we're looking at x equals -2, is the function defined somewhere in here? And it sure is. So as I'm asking for, is f of -2 defined? It sure is, because x can equal -2, and I plug it into this equation. Hopefully you remember piecewise functions from pre-calculus. F of -2 will equal -4, because -6 plus 2 is -4. So highlighter, something, keep that in the back of your mind. So now how would we figure out if the limit exists? Well, we have to look at the limit as x approaches -2 on the left side of this function. Well, which one of these equations is the left side? Left side is the less than symbol. So you have to plug in -2 right here. So we're looking at -2 times the square root of -2 plus 6 is 4. So we're looking at -2 times 2, which is -4. So that's just the left side of -2. So now we need to look at the right side of -2. Now, which one of these conditional statements is the right side? That is this equation that I can plug in here and right here. So what do we have? Is we have e to the -2 power plus cosine of -2 pi. All right, well, e to the -2 power, that's basically saying like 1 over e squared. Cosine of -2 pi. -2 pi just means we're going clockwise, but we still end up right here, so that's 1, 0, so plus 1. Does this value equal -4? I don't know what that value is, but it's definitely not a negative number, because an exponent will be a positive plus a positive. So this definitely does not equal -4. So I can stop right there because the limit does not exist. So this is definitely a discontinuous at x equals -2. It might be continuous elsewhere, but it is discontinuous at x equals -2. No reason to look at a graph of that one. All right. This is a good place to stop the video, because there's no way I'm going to get the next 3 problems done in the next 2 minutes. So I will see you in the next video.